more about all this at the end of the video, but right now let's get to the video. A brief summary of the preceding few videos. If we want to choose 4 people out of 6 to line up for a photo, where different lineup constitutes a different photo, how many different possible photos are there? We see that there are 6 ways to choose the first person, 5 the second, 4 the third, 3 the fourth, which means there's 6 times 5 times 4 times 3 ways to do this, and the order in which the people are chosen will be the order of the photo, so the order in which we choose them does matter, so that this is the result. We multiply that out, we get 6 times 5 is 30, times 4 is 120, times 3 is 360. This can be written as 6 factorial over 2 factorial. And that's obvious if you write down the 6, 5, 4, 3, 2, 1 divided by the 2 times 1. The 2 times 1 here divides the 2 times 1 in the numerator, leaving you with 6, 5, 4, 3. Multiplied together to give us the result that we know we have to have. This expression isn't quite written in terms of the 4 and the 6. To write this in terms of the 4 and the 6, we note that the 2 is how many we've got to get rid of, which is going to be 4 less than the 6 that we started from. So if we have 6 down through 1, we have to get rid of the 2 numbers on the end, the 2 and the 1. Since there are 4 numbers here, that means there are 6 minus 4 or 2 numbers to get rid of. That's what we got to do to get rid of those 2 numbers. Well, we don't write that as 2 factorial. We're going to write that as 6 minus 4 factorial. Okay, and that should be obvious why. If it isn't, go back and watch the original video, because this is just a brief summary. And that turns out to be the same thing, and that leads us to the general formula. If we were choosing our people out of n, we would take n factorial, that would be our numerator, and n minus r factorial would tell us how many of the numbers on the n we've got to get rid of. That gives us this number that we designate p of nr, or subscript n, p, subscript r, the number of permutations of r objects chosen from n. And there's another wording for that that I've never liked, never did understand it, and I do understand English fairly well. It makes no sense to me, so I'm not going to repeat it, but I did repeat it on the original video if you want to see that. Okay, now, if we want to get a group of 4, okay, so here we want to get a group of 4, out of the 6. Well, every choice we make of 4 people could have been chosen in how many different ways? Well, we got 4 people in the group. There are 4 ways to choose the first person, 3 the second, 2 the third, 1 the fourth, if we want to put them in order. And that's, of course, 4 times 3 times 2 times 1 ways to order them. There are that many orders. 4 times 3 times 2 times 1 is 4 factorial orders for every possible group of 4. Now, there are this many ordered ways to choose them. If we divide that by the number of orders in which every group of 4 can be chosen, we will get the number of groups of 4. Now, you got to think through that a little bit. There are pictures that we could make, and hopefully we'll have time to do that. But here it is. Okay, so we're going to divide this by this to get the number of groups of 4. So, well, this number is 6 factorial over 2 factorial. This number is 4 factorial. We're taking 6 factorial over 2 factorial here, dividing it by 4 factorial here. And, of course, we write that out with the division sign here, but writing it in more compact notation, that's just going to be 6 factorial over 2 factorial times 4 factorial. Now, we recall where the 2 factorial came from. It came from 6 minus 4 factorial. So now we have 6 factorial over 6 minus 4 factorial multiplied by 4 factorial, and that's the number of ways, this number of possible groups. If we were choosing our people out of n to form a group, then the numbers instead of 6 and 4 would be n and r, similar to the way they were up here, and we would get this formula for the number of combinations of our objects chosen from n, in this case our people chosen from n, also written subscript n, capital C, subscript r. Okay, so there are the formulas for the number of ways to choose r out of n in order, number of ways to choose R out of N where order doesn't matter. What good does that do us? Well, let's consider the process of choosing a 4-element subsets of the set of numbers 1 through 7. Okay? Now we're choosing a subset, so the order in which we choose the members of a subset doesn't matter. And we can't choose the same element twice. Even if we listed it twice in the subset, it wouldn't change what the elements that are in the subset. An element can only appear once in a subset. The same element can only appear once. Okay, so we're choosing 4 from 7 out of 4 elements out of a group of 7, 4 objects out of a group of 7 without regard to order and without replacement. There are C of 7, 4 ways to do that. End of story. You just have to be able to evaluate C of 7, 4. Now, I don't do that. I didn't do that. But just as an example, I do C of 8, 2. C of 8, 2, 8 factorial over 8 minus 2 factorial times 2 factorial, just putting in the 2 where we see an R, putting in the 8 where we see an N. Then we expand that. I chose to first expand the numerator, 8 factorial, 8 down through 1, multiplied together. And then 8 minus 2 is 6, so we have 6 factorial, and then we have 2 factorial. Now then, well, in the next step, I write out the 6 factorial, and I write out the 2 factorial, and I get, well, you see what I get, 6, 5, 4, 3, 2, 1 for the 6 factorial, 2 times 1 for the 2 factorial, and I choose to group the 6 down through the 1 here and the 6 down through the 1 here. This divides into this, gives us 1, leaving us 8 times 7 over 2 times 1. And then 2 goes into 8 4 times, so I end up with 4 times 7, or 28. Any factorial can be, any combination can be done in this manner, where you end up with just a product of integers. And generally, I don't ask you to multiply out the integers if you're going to get a huge number, but if you're getting a number between 0 and 100, or maybe between 0 and 1,000, then it's maybe worth multiplying the numbers out. For more detail, you can see the, I think, 3 preceding videos, maybe there are 4. I don't remember how I divided that up. I think there are 3. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphyd.vhcc.edu/vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics, up through multivariable vector calculus and introductory ordinary differential equations.